Hi guys, today I'm going to do some completing the square. So this is some extra examples and these are from Cambridge, so not from Jack Plus. So we'll start with this one here and look, we've completed the square quite a bit, so it's just a bit of revision. I will first tell you what I mean by the square, and it's that thing where you've got a squared plus 2ab plus b squared equals a plus b squared all squared. So the whole idea is you want to get this so that you can factorize it like that. And of course this could be a minus, and it's going to be a minus in the example, the first example we'll do. So the whole idea of it is, well, by completing the square, you are getting this last term here. So you're getting the last term so that you can put it in this form. So look, let's start on it. So x squared minus 3x plus 1 equals 0. The first thing you would think is, well, can I cross multiply it? And well, the point is, well, no, we can't cross multiply it because we're never going to be getting to negative 3x. Negative 1 times negative 1, no, that's not going to get to negative 3x, or positive 1 times positive 1, it's not going to get there. So if you can't factorize by cross multiplying, then that's when you can complete the square. So what I do, I take my first two terms. So essentially what I'm doing is I ignore this part here and I just look at this and I'm trying to turn that into a squared minus 2ab plus b squared. So already what I have is a squared minus 2ab. And to get the b squared at the end, well, I have to say plus half of the middle thing, which is negative 3, and I square it. So essentially this is going to be b squared here, and that's what I'm trying to get. I might colour code it. There's the b squared. That's the b squared. So people get really confused because they don't understand how we are, or why we are doing this half of b squared business. So let's continue it. Half of negative 3, so of means times, so half times negative 3 on 1 is going to be negative 3 on 2, and we're going to square that. So that's x squared minus 3x plus, we're squaring a negative, so it always becomes positive, and you'll notice this is always a positive in this position, and that's why. So plus 9 on 4. And now what we have is we have the square. This thing here is the square. So that, I'm going to write the square. And what I mean by the square is a squared minus 2ab plus b squared. So if I've got that, then I can factorize that. Remember that it becomes a minus b squared. So a is x minus b, well, b squared is 9/4, so b on its own must be 3/2. So I've just factorised that and I have completed the square. I'm not finished with the problem yet, but I have completed the square. Now notice, if you're not sure how that works, you could always cross multiply here and check. And you're going to get x minus 3 on 2 times x minus 3 on 2. I have added 9/4 onto this equation here. And well, I'm adding 9/4 out of nowhere. That is not part of it. So if I'm adding something on, I can't just add it on and leave it there just to make it easier for myself. If I minus it though, well, 9/4 minus 9/4 is 0. So if I minus the 9/4, it means I actually haven't added anything on in the first place at all. It's just I've made it look nicer for myself. And then the last bit is, well, at the end I have a plus 1. So I'm going to put a plus 1 on the end. And to make it easier for myself, I'm going to say plus 4 on 4, because 4 divided by 4 is 1, and, well, it's got a common denominator. So let's take that over here and neaten it up. X minus 3 on 2 squared minus 9 plus 4 is negative 5. So now I have completed the square and I have it factorised nicely. I can solve this in two different ways. I'm going to do it with the identity a squared minus b squared. And a squared minus b squared factorizes to a minus b, a plus b. So in this case, a is going, well, a squared, I'll start with that, is x minus 3 on 2 squared. So then it makes sense that a by itself is just x minus 3 on 2. Where people go wrong a lot of the time is that b squared is 5 over 4. So if b squared is 5 over 4, it means that b is going to be root 5 on 2. So people will forget to square root this term here, the b squared term. So let's put it into the formula. A minus b and a plus b. And now, well, we can just solve each of those. So notice that at this stage, I could have said, let's add 5 on 4 on both sides, and I could have square rooted both sides and then added 3 on 2. I would have got the same answer. In the book, for the sake of Year 11 methods, generally speaking, they use this, the a squared minus b squared, so that's why I've done that here, so that it's what you can see in your book. So x minus 3 on 2 minus root 5 on 2 equals 0. So let's say I'm going to plus 3 on 2 and plus root 5 on 2 on both sides. So that means x equals 3 on 2 plus root 5 on 2. And I could write that as one fraction there. That's quite nice. The other one is no doubt going to be the conjugate there. And, well, that's x minus 3 on 2 plus root 5 on 2 equals 0. And for the same reasons, we're going to add 3 on 2 on both sides and minus root 5 on 2. So we're going to get x equals 3 minus root 5 on 2. So there we have it. There are our two solutions. And we did that through completing the square. So just completing the square, I think the trickiest part is identifying that you need these 3 terms here in order to complete the square. People get quite confused there. Let's do another one. And this one involves something that has a value in front of the x squared, and you can't have that, you need to take it out. So in order to complete the square, you need x squared with nothing in front. So we need to take the 2 out, leaving us with x squared minus 3 over 2x minus 1 on 2 equals 0. And people are going to stuff that up because they're going to forget to they're going to put a 1 there. They're going to forget to divide that by 2 as well. So we'll divide that by 2. So everything's divided by 2. Now, let's see. This 2 I can get rid of because I'm going to be solving. But look, I'll leave it there for the time being, just because if we're only factorising, we would leave it there. So look, let's complete the square. We've got x squared minus 3 on 2x. And remember that to complete the square, we take the first 2 terms and we essentially just ignore that for the time being. So to get, this is a squared minus 2ab. We want b squared. To get b squared, we say plus half of negative 3 on 2 is b squared. So this is going to give us the square. So let's do that part first. So x squared minus 3 on 2x plus, of means times in maths, 1 times negative 3 is negative 3, 2 times 2 is 4. So that's going to be negative 3 on 4 squared. And 2, this is the square now. So this whole thing, well, actually, no, we haven't squared it yet. Let's do that. X squared minus 3 on 2x plus 9 on 16. And again, I point out to you that this is always going to be a positive here because negative times negative is positive, or positive times positive is positive. So that's our square. So we can say that's the square. And of course, that will factorise now. Just move it over here. So we have 2 So x minus 3 on 4. Now remember, over at this stage here, we have added this 9 on 16 on, and that makes it easier for us. It means that we are able to complete the square, but that 9 on 16 doesn't exist, so I need to subtract it. And then, well, the other thing we need to remember is that, well, this part that we ignored, the minus half, is still there. So I need to put that minus half on. And I'm going to make that 8 over 16, or negative 8 over 16, because then I've got a common denominator straight away. So negative 8 and negative 9 is negative 17. And now I can just solve. So as I said before, if I was doing this, usually I would divide by 2 here, because then I would get rid of the 2 and I wouldn't need it on any of these lines. I could ignore it. I've chosen to leave it there this time because people are used to just factorising where you don't solve. And if you're factorising without solving, you're going to need to leave the 2 there. But when we're solving, well, if you divide 0 by anything, including 2, you're still going to have 0. So let's now divide everything by 2, which means that we get x minus 3/4 squared minus 17 on 16 equals 0. And now we can just solve. So look, this is a squared minus b squared. A equals x minus 3/4 and b equals root 17 on 4, not 17 on 16. Be careful, it's a common mistake there. So now we get x minus 3/4, a minus b, and a plus b. So I can say this equals 0 and this equals 0, and we will get x equals 3 plus root 17 on 4, and x equals 3 minus root 17 on 4. So look, just to show you how you can do it in the alternate way, when you get to this stage here, we could have said x minus 3/4 squared, add 17 on 16 on both sides. So you'd get that, and then we would square root both sides. Here's a little tricky because you've got to remember the plus or minus. So in some ways, the a squared minus b squared factorisation is a little better because you're not going to forget that you've got a plus and a minus there. In any case, we get the same answer. So 3 plus or minus root 17 on 4. So either way, we get the same thing. And actually, I prefer this method for these. But as I said, in your book, they often do the a squared minus b squared method, and it is quite good to remind you of that difference of perfect squares identity. So they are the 2 examples that I will do for completing the square.